All right. Well, it's 10th week Friday. It's our very last lecture, and the end of the quarter. You guys are, I don't know what you guys are doing. Studying, I'm assuming. Getting ready for finals week, and all of that. I hope you guys are doing okay. I know towards the end of 10th week, towards the end of the quarter, things get a little bit more stressful and hectic. But anyway, I told this story for the last lecture, last class, and if it's okay with you, I'd like to kind of just talk and share it with you guys as well. And that, as you guys study for your final exams and prepare for all of that, I just wanted to kind of share my perspective regarding tests and exams and grades and I guess life in that manner. I know I've said it a few times before that your grades on exams or in your class does not define who you are. That you as a person are much more than your academic performance, and that in the end these things are not what is most important in life. And I think well, I don't know. I wanted to share a little bit about where I'm coming from, my story regarding that, and just to kind of give you perspective on my opinions. So, so much like I assume most of you in high school, I worked really, really hard to get good grades in all of my classes in high school, and I did very well. And so my senior year of high school, I got into my dream school. I got into Caltech, which is a few miles away in Pasadena. I got in there and I thought, man, I'm going to go there and I'm going to study physics, or I don't know, I'm going to do something awesome because I was really excited. I was into math and science and all of that, and I thought this is the place I want to be. And so so after hard work in high school, I got in there and I was very excited, and I started my my freshman year. And Caltech's also on quarter system, so around 5 weeks in, we had our first round of midterm exams, and then I realized, okay, everything is hard. All of these classes are hard. It was a rough wake-up call, right? Because I'd been accustomed to doing very well, performing, at the top of my class or near the top of my class in all of my classes in high school. And here I am at Caltech, and I feel like I'm the least qualified person there. I feel like everyone else knows their stuff much better than I do. So anyway, I passed my classes my first quarter. Winter quarter was not so great. And then spring quarter, I literally failed, I think, every single one of my classes. I think I got a D in one of the classes, and the other ones were Fs. Okay, and this was so that was very discouraging because and during that spring quarter, when I realized it felt like at the time, no matter how hard I try, no matter what I'm doing, I'm not going to do well. I'm gonna fail. I'm gonna and all this, and so I became depressed, and yeah, it was really hard for me to see those bad grades. Now, and here's another thing. So Caltech is a small university. And so all of the professors they write actually individualized report cards. You don't just get a letter that is filed, but you get this handwritten report card from each of your professors. I don't know. It's possible when you have only like 25 students in your class and stuff. And so I remember getting a report card back in one of my classes, and it said Miles Chen was the weakest student in the class. And no one's ever said that to me before. And that was hard. That was hard to hear. And you know, at that time, because up until, you know, through all of high school, I worked hard so that my grades were good, and I valued doing well in my in school and my classes, and you know, my hard work was, you know, was reflected in those things, and the fact that I valued my grades so much. And you know, when I got to Caltech and the grades were not what they were, you know, I had a hard time. I had a hard time with it because up until that point, I had seen my identity and you know, kind of my self-worth was tied up in my academic performance. Okay, because spoiler alert, I was not good in sports, and so, you know, it's not that I found my self-value in like my athletic performance or, you know, in anything else. I thought like what made me special was that I'm smart, I'm able to do well in my classes and things like that. And so a lot of my identity and how I saw myself was tied up in my grades. And then so when I went to Caltech and all of my grades were terrible, it was hard for me. And so, you know, anyway, at the time I was studying with other students who I felt comfortable with, which meant they were also other students who were performing quite poorly. And because you know, people will say, oh, you should study with, you know, so-and-so who's doing well in the class. And I understand why they would encourage that, but I didn't want to because I felt so stupid hanging out with, you know, the person who was getting an A in the class. And so I hung out with other people who were also struggling. And so anyway, in our group of 5, I think out of the 5 of us, 3 of us decided to drop out of Caltech that first year, and that was hard because it was something like going to that school was something I had treasured so much, and then to just kind of see that dream or whatever fall apart, you know, was a tough pill to swallow at the time. You know, my parents were very supportive. My dad especially said, you know, I don't want to see you this way, and you know, maybe we should consider sending you to a different school. And so at the time I thought I would just drop out, go to a community college, and then transfer to a 4-year university. My dad actually found another school in Michigan where I was able to transfer to a smaller engineering school called Kettering University. It used to be where GM trained their engineers and stuff back in the day. It used to be owned by GM, but then, you know, after the whatever, in some year they said, okay, we'll form our own independent school. And so that was Kettering University. I went there. Great school, but I don't ever have to go back to Michigan again. I grew up in Southern California, so when it hits 50 degrees, I feel cold, and then in Michigan, it turns like 20 degrees, and the entire month of January is just ice. So anyway. It was tough at the time at Caltech, having all of these bad grades and doing poorly in my classes. It was tough, but I think looking back, it realized I had an unhealthy relationship, or I had placed an unhealthy value on my grades. At that time, I had valued my grades, my academic performance so much that when I felt my grades were threatened, you know, I was tempted to cheat or do something that, you know, I never would have considered doing in high school or something. And so, you know, that revealed kind of this unhealthy value I had placed on my academic performance. you know, the fact that it affected my kind of view of self and mood and attitude also reflected that. And so, you know, I was thankful for the change of environment to kind of remove me from that, and also, you know, that experience, although as hard as it was, did help me realize that my self-worth does not need to be built around my academic performance or grades. Okay, and so that's where I'm coming from when I tell you stuff like, you know, don't worry about your grades, or, you know, that your value is not defined by your academic performance. And I know many of you are thinking of graduate school, and certainly grades do play a role in your admissions decisions and things like that. And so I don't want to say that there's no value in grades. And certainly while you are a student, you know, a lot of your effort is being put forward into kind of learning and also just demonstrating that on your exams and things of that nature. So, so I understand the kind of the struggle and this you know, why grades feel important. But I do want to just kind of emphasize that I don't want you guys to have an unhealthy view of self and put an unhealthy value on those grades, okay? I don't like seeing students face severe mental health issues like depression and anxiety, especially when they are things that I feel might be induced by some of these, you know, perhaps unhealthy views of certain things. And so, so anyway, my encouragement is, oftentimes it's good to kind of take a step back and breathe and accept that that even if your academic performance may not necessarily be as high as you wish it were, that, you know, who you are as a human is not defined by these things. You know, again, you don't want to sacrifice your integrity. You don't want to sacrifice your health, whether that be in sleep or, you know, mental health things or physical health, or even your friendships and relationships by valuing your grades too much. Okay. So anyway, that's where I'm coming from. I don't know if you guys had any other questions. In the last class, they were asking other stuff about, because I said, you know, how I ended up at grad school and ended up here in this job is a whole nother story. But anyway, thanks for hearing me out there. And you know, if you want to talk about whatever, I'm happy to listen. And if you want, I don't know, if you want more story time or whatever, I can also tell more stories or whatever. But you know, the topic that I was going to talk about today was SHINee, and I don't know if you guys are interested in that. Yes.
How did you end up at your job?
How did I end up at my job? Okay. Yeah, this is another long story, but if you guys want to hear it. So at Kettering, I studied industrial engineering, which I loved. It's the engineering of processes. UCLA does not offer an industrial engineering program. They have, you know, mechanical engineering and electrical engineering and all of these other stuff, but not in industrial engineering. And what industrial engineers do is they design processes. So things like, in what order should a task be done, or in what order, you know, along the way, how many times should somebody check in for quality, or how many approvals or things like that, you know. designing a process, not necessarily a part or a thing, but a process, so that it is either most efficient or most ergonomic. Ergonomic being good for humans that are part of the process. Like, you don't want to mentally or physically abuse the people who are part of the process, and you know, pushing a button without much thinking is, I don't know about mentally abusive, but is not a good use of a human in the process. So so you're designing for efficiency or ergonomics in that regard. Anyway, I love that, and I was interning with UPS in their engineering department, and in their industrial engineering department, and that they are the group that decided things like UPS trucks should not make left turns because left turns are waste gas because they have to wait for traffic to clear. There's a common source of accidents at intersections, and so by avoiding left turns, we can reduce accidents and reduce gas consumption and things like that. And so anyway, they had to redesign all of their routes to kind of minimize the number of left turns. I was not part of that. I was part of the package tracking team to kind of make sure, because when you order something and you track the package online, it's all done because humans are scanning each of those packages and stuff like that. And so, but anyway, that was that. I had a manager, and I had a long conversation with the manager about basically, you know, what we valued in life and things like that. And basically, at the end of the conversation, the thing I took away from it was that I should not pursue a career at UPS. Me personally, I don't want to not. I think UPS is a great company, and I think you know, a lot of people love working for them. But as far as me personally went, after that conversation, I realized, you know, this is probably not the place for me. So I tried working at another corporate job, and after some time there, I thought, well, maybe I would consider going back to grad school because, you know, again, long term, I didn't think this was a place where I wanted to spend the rest of my career. So I thought maybe I'll go back to grad school, and at the time, I was back in LA, back in my hometown, and I said I don't want to leave Los Angeles to go to grad school because I'd gone to Michigan for undergrad, and I said, you know what, Southern California is my home. I don't want to leave Southern California. So, and so I looked at what kind of programs does UCLA have, and they didn't have industrial engineering, so I decided to go for statistics because I remember in my undergrad career, I took a bunch of statistics courses. I really enjoyed them, and so I said, well, maybe I'll study statistics. And at the time, this was like 2006, 2007, statistics was not as popular as it is today, okay? The term data science had not even existed. Nobody would have known what you were talking about. Big data wasn't a thing. I mean, I don't know, the iPhone 1 was just released for the first time ever, you know? So people were still using like these flip phones or these phones with sliding keyboards and stuff, because machine learning for using the keyboard actually was a brand new thing. That's another story. And so anyway, I came to UCLA statistics. I only applied to UCLA for the statistics because it was kind of, I applied to grad school on a whim because I said, well, if I get in, maybe I'll go, and if I don't, I'll just keep working here and maybe look for another job. At first I got waitlisted, and then I guess not enough people wanted to come to the UCLA stats program, and then so they let me in, which doesn't happen anymore today, okay? Again, it was not popular. Statistics in general was not as popular, and so there weren't as many applicants. Now, for the graduate programs, we get like hundreds of applicants, if not 1,000 applicants or something, and we can only let a few in. When I came in, there were a total of 7 of us and that entered the PhD grad program, and at that time you would have like Stats 102A would be offered once the entire year, and there'd be like 35 students in it, okay? And 141 would have like 10 students or something, you would just have one section for that. And I actually kind of pulled this up. So if you go to the, so if you pull up schedule of classes and you do a search, if you change it from 19S to 09S, so this is 2009 spring, you can see, so in 2009, 102C had a total of 32 students. Okay, this would be the one time it was offered in the entire year. 141, Practice of Consulting, had 12 students. I think when I entered it was 07 fall. So 2007 fall, it was even smaller. So 140 SL, 1 of 10 enrolled. Did they even hold that class? I don't know. I mean, it was still Professor Liu teaching that class. 102A, canceled. 101A had 19 students, It was a different time, okay? And now we're like struggling to have enough spots for everybody, right? But anyway, so that's why I got in, okay? Because it was nobody was interested in statistics at the time. It was just a little bit of luck that I happened to be interested in statistics, and so anyway, I was here. I took way too long to finish my degree. It took me 8 years. It should have only taken like 5. Okay, that's like probably average. But I say, well, during that time I fell in love, got married, and had kids, and so I blame that for delaying my progress. But truth was, the truth is somewhere along the way, you have to work as a TA, and that's when I discovered I enjoy teaching and standing up here and talking and teaching stuff, and so anyway, I would often pour all of my energies into teaching and not focus on completing my dissertation. But anyway, it took me 8 years, and so 8 years later, it's 2015, so that's just a few years ago, and they say, the stats department is facing high demand for all of its classes. We need to hire more lecturers. As they said, there's a lecture job open, and I said, I'll do it. And so because I had just graduated, and because I had decent success as a TA, the department hired me, I think, without too much hassle, and so that's and so my first quarter teaching, they said, can you do 102A? I said, I've never even TA'd for that class, but can you do it? I said, okay, and that's how I ended up kind of with the 102 series. I started with 102A and just kind of started doing 102B and 102C and all of these other things. And so anyway, that's how I ended up here. A lot of, I think, a lot of luck along the way, which, a lot of people don't like to hear this, regarding things like applying for a job in college admissions, university admissions. But the fact is whether you're applying for a job or applying to grad school or wherever it might be, some kind of program, a decision, the people who make decisions have to make a decision based on maybe 1 or 2 pieces of paper that you send them, your resume or your college application, and then maybe an interview where they talk to you for, if you're lucky, a couple hours, okay? And they have to make a decision on whether or not you will be a good fit or a good person or whatever for this entire program. And the bottom line is it's not like, can you imagine choosing I don't know, like in your personal dating life or something, like based on just a quick thing, like it's very difficult, okay? And so optimal decisions will not always be made. We try to do our best. You know, whoever's in a decision-making point tries to be the best, but there is always going to be an element of luck, that at that moment the interviewer or the person making the decision happened to like yours or someone else's candidate pack or profile. You know, there's other elements like the standardized exams that try to put some kind of standardized metric to compare one another, but again, we know that standardized exams don't necessarily reflect everything that you need to know. Okay, if it did, then it would be very easy to make these decisions about who to hire and who to admit. But the one exam or a couple exams in of itself is not enough to tell you everything. And so there's a bunch of other things that go into the decision-making process, and we don't like to admit it, but luck is always going to play a little bit of it. Okay, and it doesn't feel good when you feel like you're on the bad side of the luck, on receiving the bad luck, but according to law of large numbers, we should end up getting receiving good luck every now and then. Okay, and just be thankful for those moments as well. I know there's a lot of outrage regarding this bribery, UCLA, yes, all of these elite colleges schemes going on, and definitely that is a wrong thing, and that is injustice, and it is wrong. At the same time, I feel like so much of where I ended up, I just happened to get a little bit lucky at the time, here and there. Okay, and I'm not saying that my entire life was just good luck, but I know I certainly cannot take credit for everywhere and everything that has happened to me. And so, but you guys are here, and I'm very thankful to also be here with this opportunity to teach and just blab on a little bit. So thanks for hearing me out. So anyway, I think I just got lucky. That's how I got my job here. But it's but I feel I feel like I've got the best job in the world. It's truly my dream job here. So okay, should I talk about SHINee? You guys want to? No? Yes? Oh man. Okay. All right, I'll entertain another question if anybody has a question, but if not, I'm going to talk about, yes, question in the back, yes.
What's your favorite class?
My favorite class that I've taught? That's hard. It's like picking one of your children. I don't know. It's really hard for me to say, because I think for every class I've invested a lot of time and energy into it, and just because of that, right? Whenever you invest time into something, you end up loving the thing, and so I feel like I've invested time in like each of my courses, developing materials, and so I feel like I love each of them. So that's a thing, if you're in a whatever relationship you're in, and I'm not saying like you should stay in a bad relationship or anything like that, but I don't know what I'm saying. Okay, but if you invest time and energy into something, like the feelings of love and care just come naturally with those things, right? It's like I have kids, and those kids do nothing but bring exhaustion and whatever, but like you have to just invest a bunch of yourself and your time and your energy into it, and that naturally just creates feelings of love and affection for your children, and because of that, when they smile back at you, it just brings joy. So anyway, it's not like these classes smile back at me, but I feel like I've invested stuff, and so it feels good when you hear a student enjoyed your class. That always feels good. So, I do love the entire 102 series. A, B, and C. I love them all. They're all different, each in their own way. So, but they all have good elements there. Okay. All right, we good? We ready to talk? Oh yeah, questions over here. What? How did I meet my? This now we're getting into personal territory here. She came to my church. Yeah, I go to church out in the valley, and that's where I live. And I think I was working or just about to start grad school, and then she was finishing up. She had just transferred to CSUN, and she showed up at church, and I said, hello. And I don't know. And then we started going on dates, and then whatever. Okay. Now we're married, so that's we'll celebrate 8 years in a couple weeks here. So okay. All right. Now we'll talk about SHINee. All right. I don't know if you guys have heard of SHINee or if you've seen SHINee. SHINee allows you. So SHINee is this RStudio thing, and it allows you to create these kind of interactive applets or widgets or web pages that allow a user to kind of interact with some visualizations or some data output in a bit of a controlled way that can be nice, okay? And so your very first SHINee app, you'll probably just go to File, New, and you'll choose SHINee Web App, okay? And when you do that, you can just type in something here, and then you'll click Create, and it will create this. This is the document that it will create, okay? So the very first thing that you'll create will look like this, and it will already be filled in, and you can then just click Run App, and it will create this web page, okay? And here we've got number of bins and histogram of X, and what we can do is we can drag this slider down to here, and we can explore the shape of the data, okay? And we can see that when you have just when you have like 13 bins, the bimodal nature of the data is very clear, and as you increase more, you can get kind of a finer detail of the data there, okay? So that's what a SHINee app is, okay? And when you first look at the code, it looks like there's a whole lot of stuff, and it might be a little bit intimidating, okay? But it's actually not. In my opinion, SHINee apps are very easy to create, and it's much like working with Legos, okay? In the beginning, if you, because it's just like different pieces, and you just kind of plug them together in a few different ways. So building something with Lego bricks is quite easy. But if you take all of these little elements and you take a bunch of them, you can create something quite complex and spectacular with it, okay? And so here, it just starts you off with kind of just the very basic, easiest thing where you combine a little bit of graphic output and an input slider over here, okay? And so basically, when you want to run the application, you're going to just run this line that says SHINee app, and there's two arguments, the UI and the server, okay? So it says UI is equal to UI, server equal to server. And so what we have done is we've defined something called UI earlier in the page and defined something called server in the page. UI stands for user interface, okay? And this is basically going to be what the web page looks like, and it defines kind of the things that the user can interact with, how they update inputs and get their outputs. And then, so you define something called UI over here, and then you can define something called server down here. And the server is the R code that the computer will run in order to produce the output for the user interface, okay? So if we take a look at the UI, and again, let's just kind of run the app here. So the UI looks like this, and what we see is, so we kind of generally will say UI is a fluid page, okay, versus a static page. A fluid page meaning that the stuff in the web page will change as we update the inputs, okay? And so the UI has a title. There is a slider over here that allows us to change the number of bins, okay? And then there's a histogram over here, a display here, okay? And so what we have is we say we're gonna have fluid page, and we create the title, and then in here, we say we're gonna use the sidebar layout. The sidebar layout means there's a sidebar over on this side, and then there's a main area over here. If you can look at the SHINee reference documentation, and it will talk about the different kind of layouts that are available. But sidebar is probably the most commonly chosen one. So you have a sidebar over here, and then the main layout over there. And so when you choose the sidebar panel, you've got to indicate these are the things that go in the sidebar panel, and these are the things that go in the main panel. So in the main panel, we're just putting in one thing, and that is the plot output. Okay, we're going to just run plot output, and the thing we're going to do display the output is something called the dist plot, probably distribution plot. Okay, so this is just the name of an object that we are going to display in the output. And as far as the sidebar goes, we have one thing in there called the slider input. And the slider input, okay, we can see has the label number of bins, okay? And it goes from 1 to 50, min to max is 1 to 50. And by default, the value that it starts off with is going to be 30, okay? And when we update this, okay, when we change the numbers here, the way SHINee keeps track of it is it's going to use the label bins, okay, to keep track of the values. So bins will be equal to whatever value the slider input is, okay? And that's how the user interface is designed over here. Okay, and so on the server side, however, we have to then take the input that comes in and decide how we are going to produce the output for the web page. Okay, so so here's the input. Okay, and so what we are doing is we're going to just say for the output. Okay, so the function for the server always has two parts, input and output. Okay, there's always going to be two parts, input and output. And what we're saying is the output, okay, output $dist plot, which is basically what gets shown in the plot output. What we are going to do there is we're going to render a plot. Okay, and this includes all of the code that we need to render the plot. Okay, and so the way we render the plot is there's a built-in data set in R called faithful, okay? There's a built-in data set in R, much like MT cars and other stuff. There's a built-in data set called faithful. And faithful contains the time in between geyser eruptions for the Old Faithful geyser in Yellowstone National Park, right? So you have this geothermal geyser that shoots steam every now and then, and it happens, it's called Old Faithful because it happens on kind of these very regular intervals, about every hour or so. And so anyway, that's going to be our X, okay? And basically, we could just say histogram of X, where breaks is equal to bins and colors is equal to dark gray and border equals white, okay? But what we do is, we could have just taken bins, but I don't know if you've noticed, in R, if you say, I want a histogram with 30 bins, it will create a histogram. And then if you say, I want to change the number of bins to like 32 bins, a lot of times it produces the exact same histogram, all right? And it kind of takes that number as a suggestion and not an actual however many bins you want to create. So, so to kind of make sure that we actually get the number of bins we want, we create a sequence of values starting at the minimum to the maximum, and we say the number in our output, length output, is going to be input $bins, okay? So again, when we have the user interface, the UI will pass these values from the slider input into this variable bins, and it shows up here in input, okay? The UI gets input $bins, and it's going to add one there to kind of create the sequence, okay? And so, so here we will say create a histogram where breaks is equal to bins, color is dark gray, border is white, and we have that, and it looks like this. And so when I increase the number of bins, it redraws the histogram, okay? Whereas I could, if I wanted to, I could comment this out and just say breaks is equal to input $bins here, okay? And if I reload the app here, you'll see here it starts off with 30, and if I change the number of bins, okay, the histogram actually doesn't change. And it's only when I get to around here that the bins change, okay? Because a lot of times if you just say breaks equals 10 or breaks equals 20 or breaks equals 30, it just takes these as suggestions and produces, so at a certain point, it just kind of jumps up. So that's probably not what we want, and so instead we take input bins to define the sequence that we use, and we use that those values to create the breakpoints, okay? And so now when I change it by 1, it actually has an effect on the histogram, okay? You know, there's other things we can do, like if we wanted to change the color in the histogram, we could do that, and all I have to do is in the slider input, I would just have to add another type of thing. So I'm going to just kind of look up SHINee radio buttons, because that's another type of input gadget that we can use, okay? And I'm going to go ahead and just copy this, and you can kind of look at, look up SHINee input types, and there's going to be kind of a list of all the different kinds of stuff you can have. You can have buttons and ranges and radio buttons and select choices and things like that, okay? So for here, I'm going to put in radio buttons, and I'm going to call this color, and we'll call the label that we'll put there will be histogram color. And over on the left is the label, and so we'll say we'll start off with gray, and then the value goes on the right. So we'll put in gray and red, and I don't know what we have, blue and green or something like that, okay? So we'll go ahead and do that. And then all we have to do here is just, instead of color being dark gray, we will change this to input $color, okay? Because that's what we've called the variable over here. So we've created a radio buttons, and we're going to say radio buttons color. These are our drop-down choices, and for the and we put that in here with input $color. So I'm going to go ahead and reload the app, okay? And so here we have this, and now I can choose red, blue, or green, okay, as far as the histogram goes, okay? And so this is, just like kind of, again, like Lego pieces, these are, you just take these different elements. Here I've taken this slider and this color thing, and I've just kind of added it, and you can add complexity to the app that you're creating, okay? You should check out their website, okay? If you just type in SHINee into Google, or SHINee RStudio or whatever, this will be kind of the default page. And you can look at Get Started, and there's some video tutorials to get you started. Or you can also look at articles, and under articles they have kind of start your first SHINee app, and this will talk about kind of the basic parts of the SHINee app. Okay, so here's another one that this is just part of the tutorials that RStudio has created. And here we don't actually have graphic output, we have text output. Okay, and our options are we can choose different data sets, and we can already start to see, like, okay, so for cars, what is the output that's being produced? We can see that this is basically what our outputs when we type in summary for a data set. We just say summary of the data set, and it gives us kind of the summary statistics. And over here we have output of a table, and I can reduce the number of observations to view or increase this. And basically we can imagine the code running here is just give me the head of the data set where the number of rows to show is this value here. Okay? And indeed, if we look at it, we have sidebar layout again. We have a select input where we can choose rock, pressure, or cars as our data sets. Numeric input, which is basically allows us to type in kind of numbers here. Okay, oops. And we get something here. And it's funny, you get, like, if I put in something where it's not going to work, it gives me a missing value or true, false needed. We've seen that error before, right? Because if I give it something that's not a number, it's going to return it. It's going to get coerced into an NA, right? So anyway, we have numeric input, and then as far as the main panel goes, there's two parts here. One is verbatim text output. Verbatim text output is basically what R will output into the console when you call a command. And here we have table output, and it's going to get rendered as a table. And as far as the server goes, we have a switch to be able to choose which data set we're working with, and then the summary that gets put out we call render print, and we say we're going to run a summary on the data set, and then render table where we call head on the data set with number of input equal to input $ observations there. Okay, so these are just a few examples, and basically, if you want to build a SHINee app, don't be intimidated. It's very simple. It's just a matter of kind of checking the reference documentation to see what kind of Lego bricks you can combine together there. All right, anyway, it's been a pleasure being your instructor, and we'll see you guys for the final exam. So.